All right, Algebra 2, welcome to your 6164 quiz review video for this spring 2021. A quiz we shall take before the end of quarter 3. All right, so numbers 1 through 9, given f of x is that, g of x is that, and h of x is 3x plus 6. Find the following. So when it says f plus g of x, that simply means f of x plus g of x. Okay, so I take f of x, add it to g of x. Highly recommend that second function you put in parentheses, especially when we're going to subtract it. Like here, you have f of x minus g of x. Okay, it's very important that you put this in parentheses so that you can see you're subtracting a negative 2, which means you're adding 2 to 7. All right. I don't know why I put this in parentheses, that first one, but you have h of x plus g of x. Add them up. F of x times g of x, little distribution. Again, 3 terms by 2 terms is going to give you 6 terms. Just distribute. We should know how to multiply now. That should be no big deal. Now I have g of x times h of x. I'm literally just foiling. First, outer, inner, last. And then the easiest one, because I'm not even asking you to comment on the domain, you don't have to say that x is not allowed to equal 2/5. 3x plus 6 over 5x minus 2. That's h of x over g of x. Take a look at 7, h of x minus g of x. Again, I'm subtracting all of this. I'm again subtracting a negative 2, so I'm adding 2 to 6. 3 times g of x minus 4 times h of x. Use a little distribution there to combine like terms. And I have now g of x minus h of x. So the opposite there. Just flip it around for number 7. All right, honestly, should not be a difficult page there. Should not be a difficult page. I thought for Honors Algebra 2 that this was going to be one of their easiest quizzes remaining. We, obviously, with quarantining and snow days, doesn't always benefit students here. That's what I'm learning. So it should have been an easy quiz and should be for you too. So number 10, I am evaluating g of negative 2 first, the inner function. So g of negative 2, I'm plugging negative 2 in for x right there. 7 times negative 2 minus 3. I get negative 17, so I take that negative 17 and I plug it into the outer function, f of negative 17. That means I plug negative 17 in for x. Right there, when you square a negative, you get a positive. 295 is my final answer. All right, so f of 1. Plug 1 in for x right there. 1 squared plus 6 is 7. Then I evaluate g of 7. Plug 7 in for x right there. 7 times 7 minus 3 is 46. All right, so then I have g of 3. Plug 3 in for x right there. I get 18. Then I plug 18 in for x in the outer function. So I plug 18 in for x right there. 5 times what I'm plugging in for x, which is 18 plus 1. All right, so I just keep rolling. So f of 2 means I figure out what f of 2 is. F of x is x squared plus 6, so it's 2 squared plus 6, which is 10. And then I just plug it back into the same equation. So now I do 10 squared plus 6, which is 106. G of 1, I figure out what g of 1 is. G of 1 is 7 times 1 minus 3, it's 4. Then I take 4 and I plug it back into g of x. 7 times 4 minus 3 is 25. H of negative 4. H of negative 4, 5 times negative 4 plus 1. Then I take that answer and I plug it in for f. Negative 19 squared plus 6. H of negative 1. 5 times negative 1 plus 1. And I take that negative 4 and I plug it into g of x. 7 times negative 4 minus 3. Again, just make sure you're plugging into the right equation. G of x is 7x minus 3. So 7 times what I'm plugging in for x minus 3. G of h of x. Here's what I know. H of x is 5x plus 1. 5x plus 1. That is what I'm plugging in for x. I'm plugging all that in for x in g of x. So it's 7. G of x is 7x minus 3. So it's 7 times what I'm plugging in for x, which is not a number here, it's an expression, minus 3. 7 times what I'm plugging in for x, minus 3. Distribute again, I'm left with 35x plus 4. I won't be left with a simple number there. G of f of x means g of x squared plus 6. I'm plugging x squared plus 6 in right here. 7 times x squared plus 6 minus 3. 7 times what I'm plugging in for x, minus 3. All right. Overall, should be a pretty easy page. That page should be pretty easy. Yes, I will grant you that this page is not the easiest. Last year, in your chapter in geometry about translations and transformations, reflections, all that, you did this. You reflected points across the line y equals x, and you saw inverses of each other. So find the inverse of each function. First off, f of x is the same thing as y, so y equals 3x minus 4. Inverses are reflected across the line y equals x, so x and y switch places. So if you have y equals 3x minus 4, now you have x equals 3y minus 4. And I go about solving for this y. So I add 4 to both sides. X plus 4 is 3y. I divide both sides by 3. Y equals x plus 4 over 3. You can leave it like that. You don't have to write f inverse of x. That is the inverse. Number 20, again, y equals 2x plus 8. Now I switch x and y, so x equals 2y plus 8. Subtract 8 from both sides. Then I divide by 2. Your inverse is y equals x minus 8 over 2. Again, inverses, think of inverse operations. In this original function, I was multiplying only x by 2. Now I'm dividing everything by 2. I was adding 8, now I'm subtracting 8. Opposite operations. Y equals 2x minus 7 over 3. So I switch x and y. X equals 2y minus 7 over 3. I'm going to multiply both sides by 3. 3x equals 2y plus 7. Add 7 to both sides, and then divide by 2. All right, again, we won't be able to do all these. I only have so much room. 22, if I have y equals 1 half x plus 3, I'm going to switch x and y. X equals 1 half y plus 3. I'm going to subtract 3 from both sides. I will then double both sides. Don't divide both sides by 1 half. Double both sides. Y equals 2x minus 6. That's 23 is basically the same one as 21. All right. 24, I have y equals the square root of x minus 1. So x equals the square root of y minus 1. I need to free y. Y is in a square root. The opposite of taking a square root is to square both sides. X squared is now equal to, when you square a square root, those operations undo each other. So out pops the y minus 1. Add 1 to both sides. All right. 25. Again, I have y equals the square root of x plus 3 minus 4. So x equals the square root of y plus 3 minus 4. I'm going to add 4 to both sides. Then I need to free the y by squaring both sides. Now just leave it like that. X plus y, all of it squared. You don't need to FOIL it. Definitely don't call it x squared plus 16 because that's not. Then I'm going to subtract 3 from both sides. All right. Y equals the square root of 3x minus 1 plus 2. So x equals the square root of 3y minus 1 plus 2. I'm going to subtract 2 from both sides. Here, I'm going to square both sides. X minus 2, all of it squared, is 3y plus 1. Add 1 to both sides. Divide both sides by 3. 27, y equals x squared minus 5. So x equals y squared minus 5. Add 5 to both sides. What's the opposite of squaring both sides? It's to take the square root. Now, just like, again, we talked about in class, if y squared equals 64, so if y squared is some number, x plus 5 could be 64. In last chapter, I tried to find the answer. It would be plus or minus 8. So same thing here. Y equals plus or minus the square root of x plus 5. The A parabola, which this is, it doesn't have a single inverse. Some books will say no inverse. It fails the horizontal line test. What I want you guys to write is make sure you have the plus or minus to show that no, it does not have a single inverse because of plus or minus there. All right, honestly, for Honors Algebra 2, this is probably the hardest part here. Identify the domain and range of each function. We are allowed to take the square root of 0. That's as low as it goes. So you're always going to set what is inside the square root equal to 0 because you can take the square root of 0. You can't have the square root of a negative, especially if we're going to graph it. So I take x plus 1, I set it equal to 0. Since this is a positive x on the inside, my domain is any number -1 or bigger. The domain is plus or x greater than or equal to -1. So if you have a positive x on the inside, the domain is x greater than or equal to some number always. And if you have a positive root function, that means as x, there's not a negative on the outside. As x gets bigger, y will get bigger. So if x is a -1, this is 0. The square root of 0 is 0. 0 plus 4 is 4. So this number here is always the boundary, the boundary point for the domain. It's either the smallest value that y can be or the largest value. In this case, it's the smallest value. Y is greater than or equal to 4. If you have a positive square root function, positive number on the outside of the square root, then the range is y greater than or equal to some number. You see this combination mostly. That was mostly what we saw in our notes. You have the same thing here, positive x on the inside, x minus 3, set it equal to 0. You get x is 3. So x can be anything 3 or more, greater than or equal to 3. This is a positive square root function, so the range is y greater than or equal to 7. Again, looking right at you there. On number 30, take 7 minus x, set it equal to 0. That is a negative x inside the square root. So the domain can't be greater than or equal to some number. If you have a negative x of some sort on the inside, then the domain is x is less than or equal to some number, all right? Less than or equal to 7. Now this is still a positive root on the outside, so the range is y greater than or equal to -3. And so you have another positive square root function, so the domain is y greater than or equal to 5. That's a positive 3 on the inside, so the domain, sorry, this is the range greater than y greater than or equal to 5. Domain is x greater than or equal to 7. You can answer these questions exactly like that with D and R, x and y. Okay, lastly, this is an easy page because we have the jailbreak. Remember, we're taking these second roots. The square root of 49 is 7, and I'm asking myself, how many pairs do I have if I have 8 x's? 2 goes in 8 4 times exactly. 2 goes into 12 6 times exactly. I'm looking for pairs of x's, and there's 8 of them. There's going to be 4 groups of 2. I have 12 y's, and I'm looking for groups of 2. There's going to be 6 groups exactly. All right, the square root of 64 is 8. So then I ask myself, that imaginary 2 goes into 10 5 times exactly. 2 goes into 4 2 times exactly. Now I'm taking the cubed root of 8. 2 times 2 times 2 is 8. So the cubed root of 8 is 2. 3 goes into 6 twice. 3 goes into 15 5 times. All right. Square root of 144 is 12. 2 goes into 6 3 times. 2 goes into, again, imaginary 2. 2 goes into 22 11 times. The fourth root of 16 is 2 because 2 to the fourth is 16. 4 goes into 4 1 time. If I want to make a group of 4 and I have 4, I have one group. 4 goes into 25 times. Taking the cubed root of 125, 5 to the third is 125. 3 goes into 9 3 times. 3 goes into 21 7 times. Again, all of these are going to make a clean jailbreak. 6 5 is where we have leftovers. We're not there yet. 5 goes into 25 5 times. 5 goes into 36 times. So x to the fifth, y to the sixth. The fourth root of 81, 3 to the fourth is 81. 4 goes into 28 7 times. 4 goes into 44 11 times. If I have 6 and I want to make a group of 6, well, I already have my single group. 6 goes into 6 1 time. 6 goes into 18 3 times. All right, should be a pretty manageable quiz when we take it before the quarter ends for sure. This is Yak Math Videos signing out.